So today we will be doing chapter 3, which is pair of linear equations in two variables. So let's see, what does it mean after all when we say that we are talking about a linear equation in two variables. So let's revise some algebraic concepts before we move on to the main theory of this topic. So an algebraic equation basically consists of some constants which have fixed values and variables which have changing values. Together, they are joined by some operators like addition, subtraction, multiplication, division, equal to, and then you get an algebraic equation, which we call linear when the degree is 1. The degree refers to the highest power of a variable. So far, you've done linear equations in one variable. So you must be familiar with equations of this form, like 2x plus 4 equal to 6, 4x minus 9 is equal to 75. So here, only one variable is involved, hence the name. And why are we calling these equations linear? Because the only variable involved has the highest power as 1, which makes it have degree 1, hence they are linear. But now we are moving on from one variable to two variables. So along with x, we also have another variable here, say y. So these variables and constants are represented by letters of the English alphabet, which range from A to Z. So some examples of linear equations in two variables would be 2x plus 3y is equal to 7, 5x minus 6y is equal to 78. Now I want you to grab your pen and write a few equations by your own. Any random equations, but they should have these two variables. Okay. Now we'll look into the general form of a linear equation. So for a linear equation in one variable, the general form was ax plus c is equal to 0. Here along with c, we'll have an additional term which is by. So the general form of a linear equation in two variables is ax plus by plus c is equal to 0. Here x and y are the two variables, both having power 1. So that's why it's a linear equation in two variables. A, b and c are constants and they're actually real numbers, which means they can assume any value as long as it is real. Be it whole numbers, natural numbers, integers, which could be positive, negative, fractions, decimals, rational numbers, irrational numbers, any of them. But the only condition here is that a and b cannot be equal to 0. This is a very important condition. You'll just understand this, why it's important. So if in this equation ax plus by plus c equal to 0, if I take a to be equal to 0, it implies that by plus c is equal to 0. This term vanishes, right? And similarly, if I take b to be equal to 0, this term will vanish and I'll be left with ax plus c is equal to 0. What if a and b are simultaneously 0? Together they are 0. Then both the terms vanish and we're just left with c equal to 0. Now what is the problem with these equations? The thing is that the first two equations involve only one variable. Like here we have just y, here we just have x. So they are not linear equations in two variables, but only in one variable, hence defeating our purpose. Talking about the third equation, c equal to 0, it is not even a linear equation because no variable is involved. So we can't even say that the degree of this equation is 1. So due to these reasons, a and b can never be 0, neither individually nor simultaneously. Now it's very interesting to see why this linear equation is exactly called linear. As some of you might have guessed by now, linear comes from the word line. So the thing is that whenever you take this equation, like these equations, and whenever you try to plot them on your graph sheet, so you have this xy plane over here. So for every equation, you will get a straight line. It could be like this, it could be like this, it could be like this, any which way, but it will always be a straight line. So the geometric representation or the graphical interpretation of such a linear equation is that of a straight line. We'll discuss this in further detail very soon. Now, why are we studying a pair of linear equations? Well, the reason is very obvious because of its numerous applications, especially in our day-to-day lives. So let's understand this via an example. So there's this girl, Akhila, who went to a fair in her village. The amount of cash she took with her was rupees 20. She decided to play hoopla, the ticket for which was rupees 4. She decided to have a ride on the giant wheel, for which the price she paid was rupees 3 every time. What we don't know is how many times she played hoopla and how many times she went on the giant wheel. So in algebra, mind me, okay, listen to me very carefully now. In algebra, whenever we are not sure of something, it could be a quantity, it could be a cost, it could be anything, we assume it to be a variable. So in this case, we do not know how many times she played hoopla. So let's say the number of times she played hoopla was x. And let's say the number of times she had a ride on the giant will be y. Now, how much money would she spend on the hoopla? So she went on hoopla x times and every time she paid rupees 4. So total money spent on hoopla would be rupees 4x. Plus, why am I having a plus sign? Because along with playing hoopla, she also went on this giant wheel, for which every time she went, she paid rupees 3 and she went y number of times. And total money, obviously, she had rupees 20 with her. So 20. So see, you're already ready with your first equation. But be very careful here to read the entire question. They've assigned a condition here which says that the number of times she played hoopla, that is x, 1 by 2, the number of rides she had on the giant wheel means y. So here, according to the question, ATQ means according to the question, okay. So we can say x is equal to 1 by 2y. Let's convert it into an equation of the form like this. So we can cross multiply this. I will get 2x is equal to y. Whenever a sign is not mentioned, we assume it to be plus. So when plus goes on the other side of equal to, it becomes minus. So we will get 2x minus y is equal to 0. And with this, the two linear equations are ready for Akhila. In fact, you can have it for your own case also. So the next time you walk into a restaurant, say McDonald's, and you're very hungry and say you took rupees 200 with you, and you decided to eat some burgers, 40 rupees each, and you decided to have some ice creams, 20 rupees each, but you were so hungry that you just gobbled up all the food. You just don't remember how much of what you ate. So let's say the number of burgers you had were x and the number of ice creams you had were y, and I'm going to add them because you had both of them, and amount you had was obviously 200. So see, you can even frame an equation by yourself whenever you walk into any place, be it a restaurant, be it a shopping mall, anywhere. That's why it's very important to study this chapter. Now when I individually see these equations, these are the same equations which we framed for Akhila. Individually, they are linear equations in two variables. And as a whole, we can call them a pair of linear equations in two variables. Why? Now, pair means two. So I can call it a pair, but only if the variables involved are same. Like here, both equations involve the same variables, x and y. So if I were to give you an example where the first equation was 2x minus y equal to 0 and the second equation was 4p plus 3q equal to 20, then individually they are also linear equations in two variables, but as a whole I cannot call them a pair because the first equation is in terms of x and y and the second equation is in terms of p and q. We are having different variables. Either both equations should have been in terms of p and q, or both equations should have been in terms of x and y. So all you need to remember is that for a pair of linear equations, we are referring to two linear equations having the same two variables. Okay. Now you must be remembering from linear, we were understanding that the geometric interpretation of such an equation is that of a straight line. So for one linear equation, I get one straight line. If I'm going to have a pair of linear equations, I will be having a pair of straight lines. Okay, so I'll have two straight lines in that case if I'm considering a pair of linear equations, one straight line corresponding to one equation. And when we are considering these two straight lines, there can be three possibilities. We'll discuss them in further detail, but I'll just introduce you to these terms. So we can have coinciding lines, one over the other. So they appear to be a single straight line, but they're stacked one over the other. Then we can have intersecting lines which meet at a common point. We can have parallel lines which you've also studied in geometry which never meet, they never intersect. Now let's have some examples. So it's the same case where we were talking about Akhila, and here what I want you to do is to quickly refer to that part of the video and write those equations again where we discussed that in further detail. So 4x plus 3y is equal to 20. This is my first equation. And the second equation was 2x minus y is equal to 0. So if you are asked to represent this situation algebraically, you've already done that. Because algebraically, all you need to do is write the two linear equations. Talking about the graphical representation or the geometric interpretation, you know what we do. We need to plot these equations, and you know what the plots would look like already. They would look like straight lines. So how do we plot them exactly? Listen to me very carefully now. I'm going to tell you some tricks. So first of all, you draw two rectangular boxes. Box number 1, this is for equation 1. And we'll have another box now which is going to be for equation 2. Now we are going to divide these boxes into several small boxes. So first, let's draw a horizontal line. And then we will draw 3 vertical lines like this. Do it with me so that you don't miss out on anything. So it looks like Cadbury chocolate. So we are having a bar of chocolate over here. So let's fill these boxes one by one. So first you fill it with the variables x and y. And now what you need to do is, when you are referring to box number 1, you're actually focusing on equation number 1. And here you need to take some random values of x and substitute them, and you'll get the values of y. The only catch here is that we'll try to avoid those values of x and y which render as fractional or decimal type of values. Reason is, if I get some fractions or decimals, it will be very difficult for me to plot them on my graph paper. Okay, so for our own convenience, we avoid such values. So you can write over here, wherever you are working, that for first equation, if x is equal to 0, what do we get? 4 into 0, so this becomes 0, plus 3y is equal to 20. So 3y is equal to 20, and this 3 will go down now. Multiplication becomes division when it goes from left hand side to the right hand side. So y is equal to 20 by 3. Now this is a fractional value, so we will not take it. So if I take x equal to 1, I will get 4 plus 3y equal to 20. On solving, you will get y as 16 by 3. I hope you will be able to solve this, because these equations are nothing but linear equations in one variables with which you are already familiar. Then if I take x equal to 2, I will get 4 into 2, 8, plus 3y equal to 20, implies that 3y is equal to 20 minus 8, 12, implies that y is equal to 4. So I can take these values. So x 2, y 4. So like this, if we keep on taking values, you can take x as 5, you'll get 20 plus 3y equal to 20, 20 cancels, and you get y equal to 0. We could also have some negative values of x. Let me take x as minus 1, so you'll get minus 4 plus 3y as 20, 3y becomes 24, y becomes 8. Now all your focus should be on this second chocolate bar. So let's refer to the second equation now. So let me take x as 0. So you will write like this for second equation. If x is equal to 0, you get 2 into 0 minus y is equal to 0. So basically you get y equal to 0. Similarly, if like this you take x equal to 1, you will get y equal to 2, x equal to 2 and y equal to 4. Now we need to plot these points. They don't look like points at the moment, but they are. So the first point is 2, 4. The second point is 5, 0. The third point is minus 1, 8. Similarly, here the points are 0, 0, 1, 2 and 2, 4. How are we going to plot them? So these points are actually of the form x, y. So this represents the x coordinate, that is the distance on the x-axis, and this represents the y coordinate, which is the distance on the y-axis. I'll just show you how to plot these points. So the first point is 2, 4. So 2 on x-axis, 4 on y-axis. Look for the intersection of lines, and there you have this point. 5, 0. So 5 on x-axis, 0 on y-axis. So we are here. You can even label these points. Then minus 1 on x-axis, 8 on the y-axis. So you will be here. Minus 1, 8. Okay. So these are the points for equation number 1. Let's have it for equation number 2. So this is 0, 0. this will be 1 comma 2, this will be 2 comma 4, a common point. Now what I want you to do is make use of a ruler and connect the points for a particular equation. Like join these points 2 comma 4, 5 comma 0, minus 1 comma 8, you'll get a straight line. Then join the point 0 comma 0, 1 comma 2, 2 comma 4, you'll get another straight line. So it should look something like this. Okay, make use of a ruler, don't do it freehand. And I hope whatever working you are doing is with a pencil over here. You can't make use of a pen on a graph sheet. So here we can mention the equations also. So like this is for equation number 1. You can write the full equation also if you have that much space. And this is for equation number 2. And again, you can write the full equation if you want. So we can see that they are intersecting lines. They are intersecting at a common point. Now it's a good practice that whenever you are plotting a graph, you mention the scale of that graph on the top right hand corner. So we can just write here scale. So your graph notebook will tell you if it's for 1 centimeter or 2 centimeter. It will be written on it. If the squares are for 1 centimeter or 2 centimeter. So if it is 1 centimeter, you write 1 centimeter, otherwise 2 centimeter. So 1 centimeter is equal to 1 unit on both axes. So I've written an E here. You have to be very careful whenever I individually refer to X axis or Y axis. We get an I over here, and when I'm using the plural, I get AXES axis. Okay. Let's have 2 more examples for this. So now we are having 2 girls, Romila and Sonali, who visited a stationery shop. They purchased some pencils and some erasers. So the thing is that we do not know the price of one pencil and one eraser. So let's say the price of one pencil is rupees X and the price of one eraser is rupees Y. Now let's talk about Romila. So she bought 2 pencils, rupees X each. So the total money spent on pencils would be 2X. Plus, because she also bought some erasers, she bought 3 erasers, rupees Y each. So we'll get a 3Y here. And total money that she spent was rupees 9. So you're ready with your first equation. Then let's frame an equation for Sonali, her friend. So she also buys some pencils and erasers. She buys 4 pencils, rupees X each, plus because she also got some erasers, 6 erasers, rupees Y each. Total money spent rupees 18. So with this, you're done with the algebraic representation, which was just to write the linear equations. Now for the graphical representation, again, let's make some chocolate bars. So let's make our graphs a little more delicious by cutting these chocolates into several small cubes. So like this. So we have one horizontal line and we have 3 vertical lines. Fill in the first boxes with X and Y, the variables, write the equation numbers under them and get started. So for the first equation, we are here. So you can write it in a similar manner. For first equation, if X is equal to 0, your 3Y becomes equal to 9. And this means Y is equal to 3. So if I take this as 0, here we get 3. Similarly, make use of X values to get the Y values such that you do not get fractions and decimals. If possible, just avoid it. So we can take X as 3 and you will get Y as 1. Okay, you can show the working also. If I take X as 6, I'll get Y as minus 1. Now our focus should be on this equation number 2. So here also if I take X as 0, I'll get Y 3. So you take your time to do this, totally okay. But in the end, you will get some tables looking like this. Now, isn't it very surprising that both of them are actually giving us the same tables? Well, the answer should be clear to you in a couple of minutes. So this here is a pair of coinciding lines. Okay, when you plot them on a graph sheet, I told you coinciding lines are like this, one stacked over the other. So they'll appear as a single straight line because the points are the same. But in reality, there'll be 2 straight lines which are eclipsed one over the other. So here, what we're going to do is we'll just plot it for one graph, otherwise it will make our working space look very dirty if we override those points. So let's do it. X, the first point is 0, 3. So 0 on x-axis, 3 on y-axis, label it, then 3, 1, then 6, minus 1. Grab your ruler and join this. You'll get a straight line like this. And now you just write here equation 1, equation 2. You can write the full equations also, 1 and 2. And do mention the scale, 2 centimeter or 1 centimeter equal to 1 unit on both axes. Let's take up one more example. So here you've been given 2 rails. So the algebraic representation is already in front of us because the 2 equations are given, but we'll have it in a form with which we are more comfortable. So I can pull out this -4 from here and bring it over here. So minus would become plus. Similarly, -12 on going to the RHS right hand side would become +12. So my first equation is x plus 2y is equal to 4, and my second equation is 2x plus 4y equal to 12. Equation number 1, equation number 2. For graphical representation, you know the drill. Make chocolate bars, make your studies delicious. Okay, so like this, 3 vertical lines then. The equation numbers under them. Let's start filling in the boxes x and y, x and y. So here again you can show the working for first equation. If x is equal to 0, then you'll get 0 plus 2y equal to 4. So y becomes equal to 2. So we have 0, 2. Then you can just do it by yourself also. So we will take x as 2. We'll get y as 1. If I take x 4, 4 gets cancelled. We'll get y as 0. Now attention on this second box. So we'll refer to the second equation. So if I take x as 0, 4y equal to 12, y becomes equal to 3. Now I cannot take x equal to 1, I cannot take x equal to, can I take x equal to 2? It will give me what? I'm referring to second equation. It will give me, if x is equal to 2, I'll get 4 plus 4y is equal to 12, 4y is equal to 8, y is equal to 2. So yeah, I can take this 2, 2. Then if I take x equal to 4, I will get here 8 plus 4y as 12, 4y as 4, y becomes 1. Let's plot them quickly. So 0, 2 is the first point. Then we have 2, 1. Then we have 4, 0. Then let's move on to equation number 2. So 0, 3, 2, 2, 4, 1. Join these points, you will get 2 straight lines. And you can write the equation numbers also on top of them. Like this is for equation number 1, x plus 2y equal to 4. This is for equation number 2, 2x plus 4y equal to 12. And do mention the scale on the top right hand corner.